Hello everybody. I'm hoping that your Friday is going well, or is going to go well. So we're going to finish off chain rule, and chain rule is just the undoing, or not chain rule, but U sub. And U sub is the undoing of chain rule. It's amazing how those two kind of go together. The rules for chain rule were fairly simple. Find out where U sub were simple. Find out where the chain rule would happen. You know, anytime there's an exponent, it's a pretty good idea that the function inside will be U. We would select that piece inside as a U substitution. And what would happen is we would take the derivative of that, and we would move the dx over, solve for dx, and then we would start substituting, thus U substitution, where our x squared plus 1, our thing inside of that chain rule piece, would get substituted out. And when we do the substitution for the dx, du over something, it would get rid of all the other x's. You'll know if you did U substitution right if the problem you have at the end is easier than the problem that you had in the beginning and there are no x's left in the problem. And that's ultimately what it comes down to, is U sub is taking a problem that looks gross, rewriting it to be easier, and then moving on. So we started off with one trig problem. We found out it wasn't too bad. We've got another trig problem. We're going to start off, in fact, the rest of these I believe are trig. So when I take a look at this next one, I look for where the chain rule is. And I'll tell you what, the general action of this is going to be, I would like you to try the question, see what happens, and then pause the video, try it out, see what happens, and then I will start back up. So I will give you a couple seconds for a pause, and then you can go ahead and try it out. Hopefully you gave this a shot. And you realized that u, in this case, would have equaled the x to the third. Again, not a surprise, it's inside where that secant is. And our du would have been 3x squared dx. And if I solve for dx, we get du over 3x squared is my dx. And what we should do from here is we should just do some basic substituting. We're going to take the integral. We're going to have the secant squared of u, because that's what we wanted to be simplified. We've got an x squared that would be left over from here, and we would replace the dx with du over 3x squared, and you can see that the x squareds would simplify. After that, we would say this is equal to 1/3 the antiderivative of secant squared of u du. And we'd have to ask ourselves, what is the antiderivative of secant squared? Or we could ask the derivative of what is secant squared, and we would realize that that is tangent. We would say the answer is 1/3 the tangent of u plus c. Now that's not a correct answer because it's still a u, and the problem was an x. We always need to make sure that our problem ends in either a constant, which we'll talk about later, or in terms of what we started with. We would say this is 1/3 the tangent of x cubed plus c. And we'd move on with our lives. So hopefully that was a good little warm-up. Nothing bad, nothing crazy. What I will do is I will pause now for the next question. So for the next question, I will wait and I will see, we'll see how you do. All right, so what I want to point out is that this is a little bit of a tricky problem. What a vast majority of people will do in this question is they will select u and they will look, and just like every other problem, it seems like our u should be that 5x. But what would happen if I changed that? If I did that, I'd get du is equal to 5 dx, and I would say that du over 5 is dx. And if we did the substitution, we would have gotten 1 over 5 sine cubed of u cosine of u du. So we know what the antiderivative of sine is, we know what the antiderivative of cosine is, but here's the deal. I've got this entire thing, and when I do antiderivatives, I want to make sure that my antiderivative is exactly one of these. It has to be x to the nth power. It has to be the cosine of just u, or sine of u, or secant squared of u, or cosecant of u, or secant tangent u, cosecant u, cotangent u. It has to be one of those forms. It cannot be any other form. There is no other form that we know how to take an antiderivative of. I do not see a sine cubed u times the cosine of u. That is not one of my forms. See, in this problem, whoop, wrong one. Let me go to the right page here. In this problem, our u is not going to be 5x. Now this is where it's tricky. Then what else could u be? Well, realize that when I look at this problem, there's actually two spots where there's a chain rule. There was the 5x, which is a chain rule, but before we dealt with the 5x, we would have actually had to have dealt with the third power. See, what I needed to realize is what's interesting is if I let u equal to just the sine of 5x, realizing that sine of 5x, remember this is the sine of 5x all raised to the third power, that if we let u equal sine of 5x, our du turns into derivative of sine is cosine of 5x times 5 dx, which means du is 5 cosine over 5 cosine of 5x is our dx. And if we do this substitution, if we look at this, what would happen is that our sine of 5x would replace that sine of 5x. That would just be written as u to the third power. And you'll notice that we would have the cosine of 5x here, but our dx is going to turn into du over 5 cosine of 5x. And what's amazing is that those cosine of 5x's will reduce, and the problem becomes 1/5 the integral of u cubed du. This is what I meant earlier by does the problem look easier than what we started with? See, when I did the u as just 5x, it made the problem look a little bit easier, but it really still didn't look easy. Our final u subs should always make the problem look extremely easy. Take an antiderivative of u to the third. This becomes 1/5 times u to the fourth over 4 plus c, which when I multiply the 1/5 times 1/4, that's 1/20th. U becomes just the sine of 5x again to the fourth power plus c. We call that a day. I realized that was a little bit of a tricky question. I realized there was some difficulty. So now take a look at the next one. And knowing what we just did here, try out the next one. I'll give you a moment to pause the video and give it a shot. All right. Hoping that you had taken the time to do that and not just copying off of the video. What we do is we take a look and we would, some of you may have tried 2x or x squared, and x squared would cancel this, but we still would have gotten a cosine to the fourth of u, sine of u du. Not very useful. What we should have done is selected for our u the cosine of x squared, which when we take the derivative of that happens to be the negative sine of x squared times 2x dx, or simplifying that so that we can substitute the dx, negative sine of x squared times 2x is my dx. And when I go to do my substitution, I'm going to simplify something a little bit. I'm going to do this a slightly different way this time just to show how we can save some space, not necessarily write down all of the steps here. But what I can do is I can recognize that my cosine will be traded out. This will become u to the fourth power. I notice that I have a sine squared of x here, which will reduce with this. I notice that I have an x here that will reduce with that. So you'll see that I don't necessarily have to show all of the substitutions. And that will leave me with du over negative 2. So negative 1/2, the integral of u to the fourth du. We take an antiderivative of u to the fourth, get u to the fifth over 5 plus c. We call this negative 1/10 of, our u is cosine of x squared, so we call this the cosine to the fifth of x squared plus c. Remember that this fifth in the second power, that fifth is to the entire cosine, not to the x squared, so we do not simplify that. You are done. There's nothing else you can do with this question. All right, with that said, the last question I would like you to do is this very bottom one. I would like to, again, give the opportunity, try this one out, see if you can come up with a u substitution that works, and see if you can get a correct answer. I'll give you a moment to pause the video. All right, now that we've paused the video, if I take a look, I should have selected u as x squared plus 4. Therefore, du would have been 2x dx, or du over 2x would replace the dx. You can see this x will cancel out with that x right up there. And that will leave me, I'm actually going to do something even slightly more different. I'm going to realize that this 1/2 is going to be just factored directly out. This becomes du over the cubic root of u. Now I don't like that. I'm going to call this the integral of u to the negative 1/3 du. I'll take the antiderivative of that. This is 1/2 u to the positive 2/3 over 2/3 plus c, which I can rewrite as 1/2 times 3/2 u to the 2/3 plus c. And when I simplify this, it becomes 3/4 of my u, x squared plus 4 to the 3/2 plus c, and we call it a day. It was a rather short video today. Hopefully that was a set of useful information. Do I have another set of let me just double check, make sure I didn't throw anything else in there. Ooh, I have a whole bunch of other questions. I apologize. I got all excited thinking we were done. Then we got more. Oh my goodness. Why do I feel like I'm missing some problems? Apparently not. There's just a weird line. What I will do is I will just pause for you to try out the next set of questions, try out the full set, and then I will just work them in quick repetition so that you can see what the solutions are. All right, so I'm going to work the next several questions just kind of in rapid order. I'm not going to pause in between them. Hopefully you have completed all of them, given them all a shot, see how you do. Maybe there's one that messed with you. Let's find out. So if I look at the first one, I look at this. There's no exponent on the sign, so sign is probably not my u. So the only thing that could be the u is the x to the 3rd. Du, therefore, is going to be 3x squared dx. At this point, I'll simplify it. Du over 3x squared is dx. I can see that that x squared will get rid of that, leaving me with 1/3 the integral of the sine of u du, which is 1/3 the negative cosine of u plus c, or negative 1/3 the cosine of x cubed plus c. For the next question, it's one of those questions that probably makes us think, ooh, sine and cosine, I don't want to just get rid of the 3x. I also noticed that the cosine has an exponent attached to it. So because the cosine has an exponent attached to it, I will let my u be the cosine of 3x, letting my du become the negative sine of 3x times 3 dx, or du over the negative 3 sine of 3x is my dx. I can see that the sine of 3x will cancel out the sine of 3x, so that's good. I'll get a negative 1/3 as my factor outside of the antiderivative because of this 1 over negative 3. This will become u to the 4th power du, or negative 1/3 times u to the 5th over 5 plus c, which is 1/15 cosine to the 5th of 3x plus c. Next up, we have this nasty looking thing. X to the 4th looks pretty tempting, but then I got the sine and this cosine messing with things. I also noticed sine has a 7th power. Ooh, 7th power, that's unique. Looking at that, because the sine has a 7th power, I'm going to let this be the sine of x to the 4th. Now this looks gross. There's a lot of stuff going on with this thing. But again, if I just take the derivative of the sine of x to the 4th, I would get the cosine of x to the 4th, looking pretty good, times 4x cubed dx, or rewriting that and simplifying it down, 4x cubed cosine x to the 4th is dx. And you can see the cosine simplifies with the cosine, the x cubed simplifies out with the x cubed, And once we're done, that big, nasty, long, terrible, horrible, monstrous-looking thing is really 4th of u to the 7th du. Again, I cannot reiterate this. I know we've blasted through a few of these. But if you notice, every single one of these problems, the question, the integral just simplifies down into something so basic. It seems like it shouldn't really work, but that's the beauty of integration, is that we're going to make our lives easier by using some of these techniques. So this is 1/4, u to the 8th over 8 plus c, or 1/32. Isn't that a terrible fraction? Of the sine to the 8th power of x to the 4th. I didn't need the extra set of parentheses, but I put them there anyways, plus c. Folks, there is an example question right here with the free response. I'll go ahead and we'll do the multiple choice question as well. You can see the multiple choice question. There will be multiple choice questions for the AP test that are just straight up calculus. In this problem, we can see that there's a chain rule being applied here. So if we let u equal x plus 5, then our du would have to be 3x squared dx, or du over 3x squared is equal to dx. So if we were to rewrite this problem right here, we would catch that the x squared will cancel with the x squared, and we would have 1/3 the integral of u to the 6th du, which is 1/3 u to the 7th over 7 plus c, or 1/21 of, and we're looking, oh man, 1/21, that's looking pretty good already. It's probably e, but if we do the substitution, u to the 7th, that's x cubed plus 5 to the 7th plus c. Now, what I want to point out, just real fast, if you said A, you did a wonderful job doing the u substitution and then stopped. You never actually took an antiderivative. If I took a look at B, I was looking pretty good here, but for some reason I decided, actually, if I look at part B here, what I did is I just took the antiderivative of the first term. I took the antiderivative of the inner piece here, but I completely ignored to the 6th power. We just said, that's fine, we don't need that. Be careful of something like that. For prompt C, you can see we just took the antiderivative of just this piece, hope that this went out. Actually, they did a great job u-subbing. It's just that they forgot this 3. They just canceled that. In part D, they recognized that there was a 3, but they did a weird mix of u substitution and chain rule, which resulted in a 3/7 as opposed to 1/3, 1/7. And what's interesting is that if I look at answer choices A, B, C, and D, they look so close that I might be tempted to think that there's no way my answer E could possibly be right, because 1/21 is so far off from those 4 answer choices. So be aware that even on the AP test, sometimes the correct answer is not the one that looks like all the other ones. It might be the one that is completely unique. I hope you found this to be useful. I hope that you're able to be successful in your calculus tracker. If you would pull out your calculus trackers and start taking a look at those questions. There is a worksheet that's attached, so that would probably be an excellent starting point. I hope that today goes well. I hope the weekend goes well. And like I said, I will try to make sure that I have that review. It should be up already, but if it's not, I will hopefully have it up by tonight for the 6 weeks test coming up next week. Have a great day.